In this video, we're going to look at how to work with the random variable z and find different probabilities or areas or endpoints working with a standard normal curve. So anytime you see the variable z, you know that, z is a random variable. And it's going to follow what we call a standard normal distribution. And so what we mean by that is it's a normal distribution with mean 0 and standard deviation 1. All right? And so that's just anytime you see z, that is automatic. So suppose we had the question and we wanted to find the probability that z was greater than negative 0.17. So how could we do this? Well, always for any of these problems, you're always going to want to start by drawing the normal curve. So we draw our curve. Since this is a standard normal curve, we know it is centered at 0. So that tells me that negative 0.17 is somewhere down here. And remember that probabilities correspond to areas under the curve. So in other words, I'm looking for this area right here. So how can I find that area? Well, what we can do is we can use our standard normal table to help us. So what we do is notice that the endpoint value we've got here, we could rewrite this as negative 0.17. So we're going to come over to our standard normal table. Oops, I'm going to erase this. This is some work from a different video. All right, and the z that we are interested in is negative. So again, I've got negative 0.17. Let me make my pen a little bit smaller here. So what we're going to do is we're going to look up this value. So on the left, we're going to look up negative 0.1. So negative 0.1 occurs right here. And then we look up the 7 up top, and we see that those meet at 0.43. Sorry, that's not correct. We see they meet at 0.4325. So what that tells me, if we go back to the picture, is this area right here is 0.4325. But remember, the area I want is the area to the right. Well, the total area under the curve is equal to 1. So we take 1 minus 0.4325. I'll give you just a moment. Put that in your calculator if you're working along with me. So we take 1 minus 0.4325, and this area, the area we want, is 0.5675. So this probability is 0.5675. So this is why drawing the pictures beforehand is so important, because that's going to help you figure out, are you looking at the area to the right or the area to the left of a point? And remember that the table is always going to give you the left areas. So let's look at another example. So I'm going to erase what we've got here. So let's say that I want to find the probability that z is between negative 1 and 1.2. Okay, so how could I do that? Well, again, I'm going to draw my picture. It's a standard normal, so I know it's centered at 0. Negative 1 is somewhere down here, and 1.2 is somewhere up here. So I'm going to shade in that area. All right, now, the table will tell me two things. The table is going to tell me the area to the left of 1.2. So in other words, if I look up 1.2 on the table, it's going to give me the yellow piece. If I look up -1 on the table, it's going to give me the green piece. So notice if we take the yellow area minus the green area, we're going to be left with the shaded area, this piece, which is what we wanted. So let's do that. So going over to the table, the first thing I'm going to do is I'm going to look up that 1.2. So that's going to be on my positive side. So if I'm looking up 1.20, I've got 1.2 here, 0 here, so 0.8849. So going back to my paper, I know that the yellow area is 0.8849. All right, so let's see if we can find the green. So going over here, we're going to look up -1. So that's the same thing as looking up 1.00. So going to the negative side, got -100, so 0.1587. So the green area is 0.1587. So to get the blue area, what we can do is take 0.8849, the yellow piece, and subtract off the green piece, which is equal to 1.1587. And again, remember that both of those came here from this table. So now if we go to our calculator and we put that in, we get that this area is equal to 0.7262. So this probability is 0.7262. Okay, let's look at another type of problem. So for all of these, we're given the endpoint and asked for the corresponding area, but it's completely possible that we could be given the area under the curve and asked to find the endpoint. So for example, we might say what endpoint, oops, if I could spell here, has 80% of the area above it. So again, drawing our normal curve. It's not a very good one, but anyhow, it's just an image to help us. We know that 0 is at the center. So the point that has 80% of the area above it is probably somewhere down here. And so we're looking for this endpoint. So to have 80% of the area above it, we would have 80% here. But remember that the table gives us the areas to the left. So in this case, the area to the left is 0.2. So if we go over to our standard normal table, we want to find the area. Remember, the areas are all of these pieces that's closest to 0.2. So looking through here, the area that's closest to 0.2 is this one right here. So the endpoint we're interested in is -0.84. So going back to our paper, the endpoint equals -0.84. So let's look at one more problem. So let's do another one of these endpoint problems. So now let's say what endpoint has, and let's change this to 70% of the area below it. So again, we're going to draw our curve. It's centered at 0, but now we want 70% of the area below it. So we would have 0.7 here, and we're looking for this endpoint. Well, now we don't have to do anything extra because the table looks at the areas to the left. So if we go over to our table, we now want to find the area that's closest to 0.7. Well, that's going to be on the next page. So looking to find the one that is closest to 0.7, that's going to be this one right here. So the endpoint we're looking for is 0.52.